Okay, this is part 2 of 10.7 circles in the coordinate plane. And we left off last time completing the square, solving quadratic equations by completing the square. And today we're going to actually use completing the square to come up with equations of circles. Okay, so the equation of a circle is this: x squared plus y squared minus 2x plus 6y minus 6 equals 0. Find the center and the radius of the circle, then graph the circle. Well, remember from our last lesson that the standard equation of a circle is x minus h squared plus, and then y minus k squared equals r squared, where hk is the center and r is the radius. So if we can get it into this form, it's going to be really easy to figure out the center and the radius and then be able to graph it. All right, well, before we can do that, we're going to have to do some completing the square. And before we can complete the square, it's important that we group the x and the y terms. Okay, so I'm going to kind of walk you through some steps here. Okay, so step 1, we're going to group x and y terms. And at the same time, remember, completing the square means that you got to get the constant over to one side all by itself. Okay, so we're going to group x and y terms and put constant on the other side. Okay, so I got x squared and a negative 2x. I have a y squared and a positive 6y. Minus 6 equals 0. Now we'll get that c, that constant. The constant basically means there's no variable with it. We're going to add that to the other side. So this is really x squared minus 2x. I'm going to group those using grouping symbols, which is parentheses. And y squared plus 6y, we'll group those. And then I'm going to add 6 to the other side. All right, now from here, sorry, I'm choking. From here, what we have to do is we have to complete the square on the x and the y terms separately. Okay, so number 2, we're going to complete the square on the x and y terms separately. Did I spell that right? Separately. I think so. So I'm going to take my first group here with the x's, and I'm going to complete the square there. Now, whatever I end up adding here, I'm going to have to add to the other side as well. Okay? So in this grouping, notice a is only 1, so that's perfect. Right? So when we're completing the square, remember a has to be 1. We've already moved the constant away, and so now we're going to add b over 2 squared to both sides. Okay? So b is negative 2. Divide that by 2. So let's see here. So we're going to take negative 2. We're going to divide that by 2. We're going to square that. Okay? And we're going to add that into this group, and we're also going to add that over on this side. And really, when you square something, it doesn't matter that that's negative 2. So you could just think of that as 2 divided by 2 squared, or that's just 1 squared. Okay, now on the other side, I've got a 6, and I've also got to add that 1 squared. Now I'm going to do the same thing with the y group. Again, my a is equal to 1, so this is good. My b is 6. So I'm going to take that 6 divided by 2 and square that. So really that's a 3 squared that I'm going to add in here, and I'm also going to add it to the other side. So I'll have y squared plus 6y plus 3 squared, and I'm going to add that 3 squared to the other side as well. Now what I have to do in completing the square is I have to write each one of these trinomials, which means 3 terms, I need to write that as some type of a binomial squared. Right? Isn't that what I have here? I have a binomial squared and another binomial squared. So I'm going to get the x terms to be a binomial squared. And I'm going to do the same thing with the y terms. Make that a binomial squared. And then on the right hand side, I'm going to simplify all those. So let's see, that's 6 plus 1 is 7, plus 9, because 3 squared is 9, so it's going to give us 16. Okay, so in order to write this as a binomial squared, I basically take the square root of the first term, square root of the last terms. Those are going to be my 2 terms here. So square root of x squared is x. Square root of 1 is 1. And then I always take the sign of the middle term. So that's x minus 1 squared. And then for the y's, same thing. Square root of the first term, which is y. And square root of the last term, which is 3. Take the sign of that middle term, which is a positive. So it's looking really close to this. The only difference right now is that r is not squared. Well, it's 16, so what is r? Right? So how can I write this as a perfect square? How can I write this as something squared? Well, 16 is the same as 4 squared, right? So this is really x minus 1 squared plus y plus 3 squared equals 4 squared. All right, so that means that my center is at, okay, well, what's my h? So, right, it's x minus h. Well, this is minus 1, so h is 1. And then y plus 3, well, remember, it's got to be y minus k, so that really would be y minus negative 3. So your k is negative 3. And then your radius is whatever's being squared. Well, that's just 4. Okay, and I'm going to graph this. I'm going to graph on graph paper. All right, so here's part of my answer. The fact that I have the center at 1, negative 3, and the radius is 4. We'll get some graph paper. We're going to use this graph paper a couple of times. Find a ruler. So my center is at 1, negative 3. So I know I'm going to need to go, my center is going to be at negative 3, and I'm going to have to go at least 4 below that. So I'll give myself some room in the negative y axis. So again, center is at 1, and then 1, 2, 3. And then my radius is 4. So I'm going to go up 1, 2, 3, 4. And down 1, 2, 3, 4. 1, 2, 3, 4. So that puts me, let's see, this is going to be a positive 1. This is going to be 3, 4, 5, 6, negative 7. And I'll do the same thing going right and left. So my radius again is 4. So that means my furthest point will be at 5, x equals 5. That's furthest to the right, and my furthest to the left will be at negative 3. Now, if you really want to make this look beautiful, you'll use a compass. Pretty good. All right, and there's my circle. It's got its center at 1, negative 3. And I think the radius is pretty obvious. I'm going to go ahead and label this example 3. All right, moving on to example 4. We're going to prove or disprove that the point 3, root 7 lies on the circle centered at the origin and containing the point 1, 4. Okay, so we know that for the standard equation of a circle, it looks like this. So this expresses the relationship between any point x, y on the circle, the center of the circle, hk, and the radius of the circle. Well, to find the radius of any circle then, if you had the standard equation, you could just take the square root, right, to get r by itself. So if I square root both sides, r will be by itself, and I'll have the square root of x minus h squared plus y minus k squared. Now, does this equation look familiar to you? It should. Just think of, instead of x minus h, x2 minus x1, right? The difference in the x's. And instead of y minus k, y2 minus y1, the difference in the y's. This is basically the distance formula. Now we know the center of our circle. The circle is centered at the origin, which means that the center is at 0, 0. And in order to find the radius, we should figure out the difference between that center, or the distance between that center and the point that's actually on the circle, which is 1, 4. Okay, and this is on circle. So we can call this HK, and we'll call this our X and our Y. And we'll figure out what our actual radius is. All right, so to figure out our radius, we're going to say X, which is 1, minus my H, which is 0, square that, plus Y, which is 4, minus my K, which is 0, and square that. So this is really 1 squared plus 4 squared, or the square root of 1 plus 4 squared, that's going to be 16 plus 1, which is 17. So the radius is actually the square root of 17. So now what we have to do is we have to figure out, will this point also give us the exact same radius? Okay, so this was us just finding the radius, okay? And that was step 1. Step 2, test point to see if radius is the same. Okay, so that's this point right here. So we're going to test this, because we're not sure if that's actually on the circle. And we're still going to use the same center, because the circle is centered at 0, 0. So now my x is 3, root 7 is going to be my y, h and k are still going to be zeros. Alright, so exactly the same thing. Let's see what we get here. So we're going to have 3 minus 0 squared plus, and then we'll do root 7 minus 0 squared. Let's see, so that's going to give us 3 squared. Now this is the square root of 7 being squared. So the square root of 7, and I'm squaring that. So I get 9. Now the square root and square, those are inverses of each other. They undo each other, so you're just left with a 7 there. Alright, so this one is going to be the square root of 16. So notice this radius would be shorter than the actual radius. So this point's actually going to fall somewhere inside the circle. You can reduce this if you want, or simplify this to 4, but to me right now it makes a little bit more sense to say, I know root 17 is going to be a little bit bigger than root 16. And if you were unfamiliar with that, the square root of 17 is 4.123. So that could also help. Maybe I'll do that right here. Whereas this one is exactly 4. So the radius on the actual circle is larger than this radius, which tells me that this point is actually inside the circle. So we'll say the point 3, root 7 does not lie on the circle, It lies inside the circle. And we've proven it by showing the two radiuses. So this is part of our answer. This is part of our answer. You compare those two, you can see that, well, the square root of 16 is 4. And the square root of 17 is just going to be a bit larger. Let's go ahead and calculate that. It's about 4.123. So the radius of the circle is about 4.123 units, whereas the distance from the center of the circle to this point is 4 units. So that means that this point would be inside the circle. Okay, so we can say that the point 3 root 7 does not lie on the circle. It lies on the inside of the circle. So you'd want to compare these two numbers and then give an explanation. Example 5 is going to have us finding the epicenter of an earthquake. Now the epicenter is like where it is located in the Earth's crust. All right, so the epicenter of an earthquake is 10 miles away from a certain point, which means that from this point it can be felt, right? It can be felt within a 10-mile radius. Okay, it's also 2 miles away from this point and 5 miles away from this point. So let's go back to this point. If it's 10 miles away from this point, that means 10 miles in every direction. So this is going to be like a 10-mile radius from that point. That's a circle, right? You got a center, and then you got radius. Same thing here, 2 miles away from this point. So you got a center, you got a radius. And then the last one, 5 miles away from this point. So again, a center and a radius. And where these all overlap is going to actually give us the epicenter of that earthquake. So let's talk about our circles. Each circle has a center and a radius. Okay, and we're going to graph these three circles. So my first circle would have a center at -1, -3 with a radius of 10. Second circle is going to have a center of 4, 3 with a radius of 2. And the last one is going to have a center of 2, 9 with a radius of 5. Okay, so as I think about this, I'm going to plot this point. So my y value will be 9, and I got to go up 5 and down 5 from there. So I have to go on my y-axis at least up to 14. And then this one, thinking about it, well, it's going to be at -3 on the y-axis, and I'm going to have to go down another 10. So on the y-axis, I'll be at like -13. So I have to go from like -13 to +14. So I think I should use a whole sheet of graph paper. So I'm just going to go on the back of example 3's graph paper. And now do example 5. And I'm going to use up most of my paper here. I have to go up to 14. Go up a little bit further. All right, so I'm going to just plot each one of these circles. So I'll start with -1, -3. That's my center. And then in every direction, I'm going to go 10 units. So I'll go right 10 units, I'll go left. Puts me at -11. I'll go up 10. Puts me at 7. And then I'll also go down 10. Puts me at -13. Okay, so from there, I'm going to go ahead and draw my circle. With a radius of 10. Depending on how good you are at drawing these, you could potentially have just done one extra point besides the center. I'm not very good at these, so I want to make sure that my circle is pretty exact, which is another reason why I'm just turning my paper. That one turned out pretty good. All right, second circle has a center of 4, 3 with a radius of 2. Okay, smaller circles tend to be a little bit more challenging. So let's see what I can accomplish here. Yikes, that didn't work at all. Let's try that one more time. Sometimes the smaller they are, the more challenging they can be. Let's try it from a different point. All right, that's not too bad. And then the last circle I have is centered at 2, 9 with a radius of 5. That one's a little off, but it's close enough. All right, and what we're looking for here is the place where all of these circles intersect. So these circles all appear to intersect right about, and again, my graph is not perfect, but I'm going to say about 5, 5. So that should be the epicenter of this earthquake. Let's go back to the question one more time. Yep, the epicenter of an earthquake is 10 miles from that point, 2 miles from that point, and 5 miles. Find the coordinates of the epicenter. So basically we have 3 circles here, certain distances away from each center. The epicenter is going to be where the 3 circles intersect. So our epicenter is at 5, 5. So I'm going to put on graph paper, circles intersect at 5, 5. Therefore, that is the epicenter.